Students, good evening. Welcome to the Yupp Master. Today we are going to deal the interesting topic, and which was crafted with the animated diagram. It can shows easy path to understand that what is total internal reflection. So you are all eagerly waiting for that one. Let us have a look. Total internal reflection. So we are about to know the properties of light, which is going to be reflected, refracted. So now we are discussing about that reflection of the light, but it is limited to the one medium. Total internal reflection, just you have to think that the name total internal reflection. The total incident light has been reflected into the same medium. It was happened when you have been incidented the light rays at different angles. Please see that. Let us see if you are going to take that. Have you seen this? You are having the boundary, that is air, water. It seems to be a transparent boundary between these two mediums. Now if you are going to take that air water interface, if you are going to take that, the light rays are incidented from denser to rarer. Please see that if you are going to take that, water medium is the denser medium as compared to that air. Now the light rays are incidented. Generally what happened? Let us see. Yeah, while you are going to take that source of light, this is the source of light. You can take this one. It's very clear. From that one, you are going to identify that light rays. Yeah, it's glowing. Yes, one light ray has emitted. It has been emitted from source and it has been travelled. So have you seen that it has been reflected, it has been refracted. When does it will reflect? Please identify. So it has been incidented at a particular angle with respect to the normal. Yeah, this is the refracted ray. This is the refracted ray. This is the refracted ray. Let us assume it is going to be further increased. Yeah, again one light ray which has been increased, yeah, at an angle. It is going to increase with respect to the normal. It is increased. What happened? So generally if you are going to take that, the angle of incidence is increases and the angle of refraction changes. It will changes according to that incident angle, but as you will increase, it is also increases. Please identify that. So if you are going to know that, yeah, this is theta 1, this is theta 2, you have to identify this one. So you can confirm theta 1 is greater than, theta 1 is going to be identified. This is a theta 1 and theta 2. If you increase that angle of incidence, what happens? Let us see. Again you have been increased. So from first one, now with respect to normal, it's going to be. Now I am going to change the angle of incidence. What happened? The angle of refraction is also changes. But I am going to take that, this is a special case. You have to look into that matter, that is, I am going to increase gradually, the angle of incidence. What happened? It is going to be refracted, but at a particular angle. The light ray, the refracted light ray traces that at the boundary. Nothing but the refraction angle is going to be 90 degrees. It is very clear. Now you can easily identify that. It's very clear. So this is about, yeah, this is about, yeah, 90 degrees. So the angle of refraction is going to be 90 degrees. Can you say this is the critical angle? Yeah. Yes, this is the critical angle. Please take that. So the angle of incidence at which that angle of refraction becomes 90 degrees, that is the critical angle. Already we have discussed about this one. We did the problems and we have calculated that critical angle for different materials. So you know, while you are talking about that critical angle, you have taken that water and glass and diamond, all these things. So if you are comparing that refractive index is very less, then the critical angle is going to be more, yeah, as compared to water and air and diamond and quartz. So the water medium which has that critical angle around 48.75, which is approximated as 49. Now it is very clear, we are going to know about that critical angle. How you can define the critical angle? So suppose anybody is going to ask that critical angle, what is the definition of the critical angle? Critical angle is the angle of incidence at which the angle of refraction becomes 90 degrees. This is a one ray which has been identified with your different colors. All these are identified, first one, second one and third one. These are all going to be traced with a one color. Yeah, yes. Let's see, if you are taking that, this is a one domain, up to this domain there is no reflection, there is no total internal reflection. Whenever you are considering that critical angle, that is the one reference. Critical angle is the one reference which can gives that the differentiation about total internal reflection and refraction. So if you cross this angle, just you are going to incident that angle less than critical angle, more than critical angle. If you are going to take that, this portion is going to be less than critical angle. What happened if you are going to incident the light rays less than that of critical angle, they are going to be refracted along their direction. So the angle of refraction depend on the angle of incidence, that is very clear. Now if you are going to take that, if you increase that more than that of angle of incidence, what happened? This is going to be taken, yeah, this is limited to denser medium. That's called, from this portion you are going to take that, yes, please take that, this is a one portion, you can confirm, yeah, please take that, yeah. If you are going to look into that matter, this is a shaded area, that shaded area indicates the light rays are refracted, it is very clear. In this range, if you incident any light ray, that is going to be refracted, no doubt at all. But what happened after this region, if you are going to take that critical angle, the angle of refraction is going to be 90. But after that you are going to take that increasing, just you are increasing the angle of incidence, you are going to increasing, you are going to change that angle with respect to the normal. This is, you can say this is one angle, yeah, you have been increased, yes, here also you have been increased that angle. Here angle of incidence is critical angle. Here you can take that angle of incidence theta I is greater than theta C. Theta I is much greater than theta C. So, are you getting that point? Please have a look. All the incident light rays are going to be reflected into the same medium. It is nothing but total internal reflection. It is the phenomenon of total internal reflection. This is very useful in working of an optical fiber. What happened? These reflected light rays are limited or returned back to the same medium. In case of optical fibers, what happened? They will reflected, again they will reflected, and they will carry the information, that is, the information has been carried at high speed within the glass material when the fiber has been immersed in the water medium. When the fiber has been immersed in air medium or any other, it is going to be, the fiber has been placed in any medium. So, the communication takes place with the help of fiber, optical fibers. So, if you are going to take that one country which has communication relations through the sea basin also, it is possible. Yeah, that is very clear. That is the next case, we can take that. Here all the light rays are incidented, get back, right. What do you know about that total internal reflection? The phenomenon of incidenting the light rays are going to be reflected back into the same medium. Simply, all the incident light rays above the critical angle are going to be reflected from the boundary, or they are going to rebound, they are going to return to the same medium. That is, when you compare to denser and rarer, that is very clear, you can know that. Yeah, simply you will confirm. It is the observed phenomenon. Whenever you have been incidented the light rays greater than critical angle, all the incident light rays are going to be reflected into the same medium. The total incident light ray beyond that critical angle, it is a phenomenon of total internal reflection, very clear. It is going to be observed in this case also. Now, you have to see in different medium. Now, you are taking that air and water, that is, let us see, this is another medium, we can take that. Yeah, we will go for, this is a one case, let us assume this is one case, this is the rarer medium. This is the rarer medium, this is the denser media. Yes. Now, what happened? It is going to be less than that one. This is going to be theta I is going to be less than theta C. Yes, if you are going to take that, theta I is equal to theta C. What is theta I? Angle of incidence. Theta C is the critical angle, that suffix C indicates that critical angle. Again you are going to increase that angle, it has been reflected. We have taken that rarer medium, the combination, this is a glass and this is another material. Suppose in the glass materials, if you are going to take that quartz glass and silica carbide glass, both are having their different refractive indices. So, two media, first one and second one, as compared to the density of the media is different. Now, you are going to take that, this is the case, theta I is greater than theta C. Here, this is the light ray. What happened? It has been reflected. It has been reflected back. That's what it is. The yes, you are going to take that rarer medium and denser medium. This is the normal. You are going to take the measurement of the angle of incidence and angle of refraction also. Now it is very clear you are going to take that critical angle. Yes, this ray has been refracted through the interface of the boundary at 90 degrees as per the definition of the critical angle. You can understood, but above that, above the critical angle, suppose I have taken one ray. If I am going to take that one ray, yeah, it is also going to be here. Now you are going to take that one light ray which has been incidented at an angle. This is also theta. What happened? In that range, if you incident more than that theta value, it is going to be reflected back into the same medium. That is also total internal reflected. In these rays, you will get the many rays, all the incident light above that. Now let's go for, yeah, once again you can look into that matter to recap that what we have learned. So simply you have been incident to the light rays other than critical angle is not a correct, but more than critical angle, that is very important. They are going to be total internal reflected light rays. Now let's go for that. When an angle of incidence is greater than the critical angle, then there exists a total internal reflection. What happened instead of, please see that, instead of refraction, there exists a reflection. That is, the incident light rays are going to get back into the same medium. Whenever light is allowed to move from one medium to another medium, they will pass and there exists a refraction. But after that, when you are going to change the angle of incidence, it is going to exhibit that different phenomena, that is total internal reflection. So instead of, yeah, that's what you have to study that. Yeah, instead of refraction, it undergoes, instead of refraction, it undergoes reflection into the same medium. Such phenomenon is known as total internal reflection. It's very clear. Yeah, let's take that one material that is of denser medium as compared to air. Yeah, you can take that water in the one beaker, just you can see that. You have to see that now. Yeah, you can take that, these rays, yes, these rays are there now. You are going to take that OA, yeah, OM, OA, OC, and you can get that OE. Here that refraction will exist, but what happened, let's see that, yeah, here OG is the angle, yeah, it is going to be a special case. Yes, you can take that, yeah, you can take, this is the total internal reflected light ray. It is very clear. Yes, you are going to observe that now. It is going to be, yes. Now you can see very clear. This is the case we are going to take that. This is the case. We have to see that this ray is going to be total internal reflected ray. Simply it is going to be known as total internal reflected ray. In the short form, we would like to know the TIR, total internal reflected ray. Now let's go for another case. Yeah, we are going to take that expression and all these cases, special cases, when you have taken the normal, so you have been measured that various angles, light has been incidented at various angles and there exists a slight variation in the angle of refraction. Yeah, it has been measured, okay, but only the one thing you can take that special case, this is the 90 degrees, yeah, which is going to be identified. It does not get that, yeah, it does not get the total internal reflection, but beyond that it is going to get the reflection, very clear. Now let us have that, yeah, along OA, yeah, what we have given that, we have discussed about along OA, OB, OC, OD, OE, OF, yeah, all these are going to be different rays which are described by their angle of incidence, it is very clear. Now conditions for total internal reflection, what are the conditions for the total internal reflection? If you are going to look into that, light rays are going to be entered from denser medium to rarer medium. First condition, light rays are going to be entered, light has been incidented from denser medium to rarer medium. So denser medium to rarer medium, you can take that examples, water to air, glass to air, glass to water. Glass to water is also identified, it is very clear. If you are going to take that glass, it is a denser medium as compared to water, it is very clear. Now the rays of light must travel from optically denser medium to optically rarer medium, it is very clear. Denser medium to optically rarer medium. What about that cases? You are going to take that water and air. Yeah, you will take that glass and water. Yes, it is very clear. If you are going to monitor that, you can take next one, diamond to water or diamond to glass. These are all different transparent substances which are allowing that light rays, incident light rays for their propagation. It is very clear, but the condition is you have to get that light rays are entered from water to air, glass to water, diamond to water, diamond to glass. It is very clear. Simply high refractive index to the low refractive index. Yeah, refractive index is the one criteria to guess that whether it is going to be denser or whether it is going to be rarer. Now let us go for first condition is very clear. Now let us go for second one. Please have a look. Yeah, this is very important. The angle of incidence in optical denser medium is greater than that of critical angle. It is very clear. Obviously, you are taking that. Yeah, we are all talking about that. Yes, it is going to be, yeah, rarer. This is the denser. Now, let you know, yeah, this is theta c, but the light rays are above the critical angle. The light rays are going to be incidented above the critical angle. So this is the case, this is the angle, theta I is greater than. Yeah, you have to take that angle of incidence must be greater than angle of critical angle, that is very clear. Yeah, must condition, otherwise the light rays are going to be refracted and they are going to be escaped from that one medium to another medium. So, generally while you are coupling the light from one medium to another medium, there exists a light rays which are going to be escaped from that medium. That at the coupling zone there exists a slight loss of light energy, yeah, and you need to go for problems while you are discussing about these problems. Generally you can take that angle of incidence is a one criteria, and refractive index also one criteria, right. Please have a look. Yeah, problems based on total internal reflection. Let us say that if you are going to, generally they are going to ask that theta I incidence yeah, that is theta r angle of refraction that is very clear. Now you will take that, you can take that this is mu1 and mu2. So when the light rays are entered from, this is the rarer medium and this is the denser medium, the light rays are going to be entered, they are going to be refracted at 90 degrees. This is the first medium, this is the second medium, this is the first medium. Let us assume. So by applying the Snell's law, what happened? You can see that sin theta I is equal to mu2 sin theta r. Now you can take that at the critical angle, if the angle of incidence is equal to critical angle, then there exists a angle of refraction 90 degrees, that is mu1 sin theta c is equal to mu2 sin 90 degrees. It is very clear, we are going to take that the problems based on that angle of incidence, at which angle you are going to be incident to obtain the total internal reflection. Suppose you are going, you have to incident the light rays, but you need to choose that what is the angle of incidence, at what angle does it goes to total internal reflection. Please, here from this condition we can derive that. What is that condition? This is a criteria, minimum criteria, it has to cross that theta c, which is known as critical angle. Yeah, now it is very clear, mu1 sin theta c is equal to, what about mu2? 1. So this is also 1. So sin theta c is equal to 1 by mu1. It is going to be generalized expression. It is going to be generalized expression. Its refractive index is known as mu, and it is c. Yeah. Now you can take that the generalized expression of this equation, that is sin c is equal to 1 by mu. Yeah, that is the case we can discuss. Now if you are going to take the problems, see, you can find out that set of values that you will find out. Mu is equal to 1 by sin c, that is a one problem. If you are going to take that mu, it is going to be 1 by sin c by the conditions. You are going to calculate different model problems. Let us see what about that problems, please have a look. Yeah, light ray enters from glass to water in order to achieve the total internal reflection. Yeah, please, the space is limited, we will use that. It is very clear, we have obtained, this is the basic relation. Let us go for problem solvation. Now go for this one. Yeah, what is the case? Light has been incidented from one medium to another medium, but here you need to find out that the angle of incidence must be greater or lesser or equal, but condition is to achieve the total internal reflection. That is very clear. The light ray enters from glass to air, it is very clear. Yeah, glass to water. Here they have given glass to water. Yeah, as compared to glass, water is a rarer medium. Now it is very clear. Take this diagram. Yeah, you will take that. This is water medium. You will take that water medium. This is the glass medium. Now we are talking about that this is mu1, this is mu2. Generally its value is 1.33, its value is 1.5, very clear. So we are having the basic information regarding to the problem, but we will find out that solution. To achieve the total internal reflection, what you have to do that? I know that the critical angle is a one reference angle to decide at which angle does it goes refraction, does it goes total internal reflection. Let us see. Let us calculate the critical angle if you are going to take that. Yeah. Yes, you are going to take that. Yeah. Right. This is the critical angle. It is going to be 90 degrees. Very clear. But you need to calculate this critical angle. Then it is easy to decide. This is the condition. So if you are going to take that angle is going to greater than the critical angle, that is very clear. Now by apply Snell's law, you will solve that. Apply Snell's law. That is, you can take that mu1 sin theta c is equal to mu2 sin r. Very clear. Now you are going to substitute that values also. 1.5 sin theta c is equal to 1.33 sin 90 degrees. Why? In bracket, if theta c is equal to theta c, yeah, you have to take that. Yeah, you have to take that. This is the condition. Theta I is equal to theta c, then theta r is equal to 90 degrees. That is very clear. Now from this one you will calculate sin theta c is equal to 1.33 by 1.5. Now you will get that theta c is equal to sin inverse 1.33 by 1.5. You will clear. Now you will get that theta c is equal to sin inverse. While you are taking that ratio, it is going to be, yeah, you are going to get that 133 by 150. You are going to take that 0.86, again 6 and 7. Yeah, okay, you can get that 0.8667. So theta c is around 61 degrees, around. Totally you will get that approximately 62 degrees. Yes. Yeah, 60, more than 60, nearly you will get that value. That is, you can decide that now. It is going to be, yeah, what is the answer? If theta c is going to be 62 degrees, you are going to achieve that this more than 59 degrees. You have to take that more than 59 degrees. More than exactly you have to decide, that is theta is going to be greater. Yeah, it is going to be greater than 62 degrees. around 60. Okay, from the given data you can confirm that is greater than 59 degrees, right. Let us go for another one. Yes, they have given one problem. The ray of light travelling in a transparent medium of refractive index mu falls on a surface separating the two media which are having their refractive indices, yeah, from air at an angle 45 degrees. Yeah. For which of the following value of mu the ray can undergo total internal reflection? Simply they will put the restrictions on refractive index value in order to achieve the total internal reflection. While you are going to take this kind of problems, you have to know the relation between refractive index and critical angle, that is very clear. You know the relation, that is sin C is equal to 1 by mu. This is the generalized expression. Yes, what they are asking here, you need to estimate mu value 1 by sin C. Let us assume for total internal reflection mu is going to be 1 by sin C. Yeah, that is a condition, mu is going to be 1 by sin C. Let us assume this 45 degrees is going to be angle of incidence. It might be equal to critical angle. Let us see. If so, you will get that answer which is going to be having the relation mu must be greater than that of 1 by sin C. That is very clear. Now, let us see that. Yeah, you are going to get that. Take the ray diagram. Yeah, you will take, this is a one important. This is the water, what they have given, water medium. This is the air medium. Now you can decide, yeah, that angle here. So you know this is mu, this is the mu1, this is the mu2, that is equal to 1, but you are going to take that, you are going to limit the value of mu1. How you will get that mu1? You will get that 45, let us assume. So mu is related to critical angle by this expression, but can you guess that in order to achieve the total internal reflection, what is the mu value? Our condition is, in order to get the total internal reflection, that it is going to be greater. Now let us see, that is yeah, you will take that mu is greater than 1 by sin 45 degrees. Mu is greater than 1 by root 2. So mu is greater than 1.414. Yeah, you will take that mu is greater than root 2. If they have given answer, please check it. You are all going to have that. This is the first step and second step. Let us see that answers, let us see that options. Yeah, we are going to take that 1.33, 1.414, 1 point, yeah, this is the option which is not visible. So mu is equal to 1.414, mu is equal to 1.25. So this is root 2, less than root 2, less than root 2, but this is the case, mu is greater than root 2. This case is going to be correct. Yeah, this is the case, we can confirm. Now take that mu is going to be greater than that of root 2 value, that is 1.5, which is a suitable option for this question. Yeah, this one. If you change that, refractive index value, it might be affects the total internal reflection, right? Very clear from that. It was by the trial and error method we are going to get the answers. These type of questions are going to be getting the answers with the trial and error method from the given options and by solving all these things. Yes, we are going to take that applications of an optical fiber. We are having that, it is widely used in the telecommunication, but how it is working, you are going to take that. Working of optical fiber is from total internal reflection. These are all from total internal reflection. Yes, please take that. Yes, sparking of diamond, why it is going to be brighten. Yes, sparking of diamond, and next mirage formation and looming. Yeah, an empty test tube inside water shines like a mirror. These are all the applications of total internal reflections, but it was highlighted optical fibers. Yes, if you are taking that optical fiber, it plays a vital role in the communication field, and sparking of diamond is the intrinsic property. Because of that total internal reflection of the incident light rays in the diamond, they are going to be brightening. Very clear, that is the intrinsic property of the diamond, it does not change, but working of optical fiber is going to be obtained to have the better advantage. So, if you are taking that optical fiber, it is having like that, is a core which is surrounded by the glass. This is the core. The incident light rays are going, yeah, they are total internal reflected light rays, total internal reflection. So, when you are going to increase that angle of incidence, it is going to theta is greater than theta c. It gets the total internal reflection within the core material, within the glass material, but at each and every reflection point, at each and every reflection, there exists some gaining of energy, while in case of light rays. So, after 10 kilometers they will be amplified a little bit, but you can have the advantage with the less input. With the less input energy, you will get that, you will transmit the signal for large distances, which are going to carry that information. That information has been coupled with the light waves, and it are going to be arranged to get the total internal reflection, which are going to be incidented greater than that of critical angle. So, it is very clear. So, in the coming classes also we are going to discuss with the animated diagrams and all well crafted diagrams and lectures. With the aid of modern teaching methods, we are all going to provide the best facility to the students in this situation. Please utilize this opportunity and convey to the more number of people and your well wishers about this Yupp Master. Please do the favor for all your well wishers. Thank you very much. Have a nice day.